And the story is the fictional world of the pirates and the marines and the people with supernatural power known as Davy food user. And today I'm going to talk about one of the devil food users called the Fujitaro. Yes, and he is a marine admiral, and he's a blind and sour man with a clam personality and something. And anyway, his devil fruit ability is he can control the gravity. Then let's go into see one of the screens. Okay, this one. Okay, you can see in the screen in the animation. So everyone survives because Solos cut the meteors of the Fujitaros. And so my question and the problem I found is everyone's near the impact size still survives under such large of a meteorite, and how large would be actually this construct be. So in the beginning, let's estimate how large is the meteorite is. So I just use the characters, the people, the height of a people as a reference, and if we assume the people is 1.75 meters high, and then we can estimate the diameters of meteors is about 1.2 kilometers. It's a very, very huge one. So what is the impact energy? We just, so the impact energy is actually transferred from the kinematic energy. So if we know how large is the diameters, and we assume the density of the meteorite is about 3,000 kilograms per cubic meters, and this assumption is from Hilton's papers. It assumes that if the meteorite is made of the rock, the density will close to these values, and we also assume the impact velocity is close to the 20 kilometers per second, and this is also from one of the papers. And he also estimates the velocity is about 11 to the 20 kilometers per second. So the energy is about 5 times 10 to 20 joules, and this is close to the 130 gigatons of the TNTs, which means it's a very, very large energy here. So also I calculate the crater dimensions. So the large D here means the diameters of a crater, and also the equation in the second one is the depth of the craters. So also we use some the assumption, and also the meteorite, the diameter of a meteorite we estimate in the previous slide, and we also assume the impact angle is about 45 degrees here. So we can guess that the depth of the depth of crater is about 4.6 kilometers, and also the diameters of the crater is about 30 kilometers, which is a very, very huge one. And also calculate the thermal radiation, and the RF here is mean the fireball radius, which means within the radius, all of things will on fire and becomes, all of things will be on fire. So this is related to the energy. Oh, sorry, the notation is wrong. It's related to the impact energy. So if we know the impact energy, then we can calculate that the radius is about 16 kilometers. So within the 16 kilometers, all of things will on fire. And this is called, the other parameter is called the thermal exposure, which is implies the how many energy we will get per area within the certain radius here. So I use if at the 190 kilometers, the thermal exposure is 7.2 millions joules per areas, and this value is related to the closing ejection threshold, which means within 190 kilometers, all of the clothes were on fire, which is the disaster. Yeah. Also, the meteorites will meteorite impact will have the earthquake, not earthquake, the seismic impact. So this seismic impact can estimate within the 16 kilometers and also between the 16 kilometer to 700 kilometers. So in our case, within the 16 kilometers, the magnitude is close to 8. And within between the 16 and also 700 kilometers, the magnitude is close to 6. So typically, if the magnitude is larger than 7, all of the construction will fall down. So you can tell within the 16 kilometers, all of the construction will fall down. So the conclusion is, based on the calculations, I think the Fujitaro's meteors is physically far more disconstructive than the show in the animate. And so if this is reality, in reality, it will be a disastrous catastrophe, and I think all the people around, at least around 190 kilometers, all people will die, I think. Yeah. So I also found the simulator in the website, and he can simulate how does it look like. Yeah. And I just put the same physical condition in what I assumed in the papers, in the slide, and I put the center in the Hsinchu city. Yeah, so you can tell the crater can covers almost all of the Hsinchu city. Yes, and also it also can show how the fireball looks like. So the fireballs also covers all of the Taiwan's islands. Yes. Yeah, and also this is the shock wave. You can see the shock wave almost extended to the mainland China, and also it will have at least a 5 kilometers per second peak wind speed, which is very, very large, and close to 8 magnitudes earthquake, and Taiwan will at least covered by 5 magnitude earthquake. Yeah. So that's all. Thank you.
Any questions, comments?
Yeah.
Go ahead.
Oh, sorry.
I really like your presentation. I'm not sure if this is maybe out of the scope of this presentation, but do you know of any, I guess, sort of atmospheric consequences that an asteroid like this could have here? Because you look at the, what is it, the sort of earthquake and the fireball and all those aspects. I just want to know your, I guess, knowledge on what sort of atmospheric consequences there can be.
Did you mean whether the atmosphere will influence the meteorites, or?
More like, I don't know, if we get this crater, where does all that go? Like, does all the rest rock and dust, does it expel out into our atmosphere, and does it have sort of a, for example, can Taiwan be covered in dust and gas and stuff like that?
Yes, I think so, but I didn't consider about that in my calculation. Yeah. That's a very good question.
Gas is possibly follow the shock wave.
Follow shock wave?
Dust.
Probably.
So how do you estimate the size of 1.2 kilometer? Could you explain again?
So, okay, so did you see there is the small humans in the...
Yeah, oh, okay,
the,
this is
right?
human. Okay.
Yeah. So I just assumed that human tall is about 1.7 meters, and I use it to estimate the meteorite size. Yeah.
Okay, so there are 1,000 humans in here, about.
I think more than 1,000.
Okay.
Yeah.
How about the velocity?
The velocity, okay. So the velocity I found in the papers, they mentioned the velocity at least is 11 kilometers per second, is something related to the escape velocity in the Earth. But I said the 20 here is common use in the paper calculation, so I just assumed the 20 here. Yeah.
Okay. So velocity, it depends on the velocity square. So if velocity is a little bit slower, say if it's 10 kilometers, then energy is just 1/4.
Yeah, if the velocity is smaller, then the consequence must be changed, but still will die a lot of people. Yeah.
Okay.
Any further question?
When you estimate the size of the rock, did you consider the parallax?
Sorry?
Could you go back to the previous? Because you mentioned that you consider the size of the rocket and the human, right?
Yeah.
It's the 1.75 meter. Do you consider the parallax between the rocket and the human?
I think because this is a very good point. But I think in this point, the meteorite is very, very close to human. So I think we can ignore that.
But if it's close to the human, but the speed can extend it to impact the Earth. They don't have a react time.
I see. You mean maybe human already died before that?
Yeah.
Yeah, that may be true. Yeah.
10 kilometers per hour.
Yeah, it's very, very quick.
I think human animation is stronger than this.
Okay. If no question, let's go to the Git Kahoo.
Okay.
Does everyone join? Okay, then let's start. Oh. Okay, so let's start. I think the question is very easy. So which formula is used to estimate the impact energy? Looks, it's very easy, right?
They cannot see the
Oh, sorry. Who answered that? Okay. Second one, about the impact energy. What is the impact energy years? Okay. If okay, it's the impact energy again. Okay. Oh, Thomas becomes the first again. What is the postal relationship? Yeah, approximate. 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 Yeah. Only one people. Okay, I think this one is very difficult.
You said they were easy. Very easy.
Jeremy is not cheating.
The radius of a fireball. You can choose a reasonable one. Okay. So this one is easy, right? who answered the first one? Yeah, Jeremy. True and false. Yeah. Yeah. Excellent, excellent. Okay. Jeremy, congratulations.
Congratulations. Can we look at the most difficult questions?
The most difficult question. Okay, wait a second. What is this one? Skip. Report. Who can I see a report? This one? Ah, right. This one. So this one is very difficult. So the relation between the crater depth and the crater diameter is the crater depth is equal to the diameter over the 2 square 2. So it's close to 3.
You're showing it in a different form.
Yeah, right. Yeah, I'm sorry, but I think maybe people can estimate the approximate values.
Sure, we can calculate 2 times square root 2.
Yeah, we are astronomer, right?
And then another quiz, is there, how about second one?
This one, also, this one is, as I mentioned in the slide, according to our estimate, the radius is about 16 kilometers. The fiber radius is about 16 kilometers. Yeah.
Okay, thank you. Any other questions about the quiz? Everything clear? Was it easy?
Okay.
Okay, if no other question, thank you, Jyun for excellent presentation.
Thank you. Arigato.
Thank you. Okay.